So we're going to talk about a normal distribution. Normal distribution is when data varies randomly from the mean. It forms a bell-shaped curve. Do you see this bell-shaped curve? All right. So if I were to hear the word normal distribution, it forms something that looks very similar to this. And your data, if you did a dot plot of your data, this is what it would look like. So if you took data, dot plotted it, it would kind of make this shape. And thus, that would be a normal distribution. And what a normal distribution means, it varies randomly from the mean. So good random data should hopefully turn out to look something like this somewhere on your graph. It might be kind of skewed to the right or skewed to the left a little bit, but when you get to your mean, and from the mean, and you kind of look at where the mean is, the data, you should have this shape for really good data. And it's called a normal distribution. Now, if you look at this picture, do you see how majority of the data is right here in the middle? If you think of area under this big curve, can you see how the majority of the area is right here? And that's right there. It tells you 38% of the data is in this little area. Oh, thank you. 68% of the data, I cannot read. Mine's really ugly here. It's kind of hard to see. But 68% of the data is within this. So if you think of area, could that mean 68% of the area is right there in that big hump? Kind of like a camel hump. Now, and what you need to know is that's also within one standard deviation. So if we have a normal distribution, 68% of the data will probably be within one standard deviation. This is kind of letting you understand what a standard deviation does more. It tells you 68% of the data should be within that, if it's normal. Next, look at the next bracket. See how we go out again? See how we go to a second standard deviation, here and here? See how we're picking up some more area? What does it say here? 95% of the data on a normal distribution curve of data should be within 2 standard deviations. So basically, within 2 standard deviations, do you have a majority of your data? Yeah, you have 95% of it, so you're lacking 5%. So 5% is outside of that. Okay, on a normal distribution, let's go farther. After 3 standard deviations, you have 99.7% of the data probably. Is that basically all of it? Yeah, so guess out here and out here is about 0.3% of your data. So maybe an outlier or two. Again, it's based upon it being a normal distribution. On a dot plot, you get this picture. And if you have that, then 1 standard deviation would have 68, 2 standard deviations have 95, and 3 standard deviations have 99.7% of your data embedded in that. All right, let's look at this question right here. A teacher has 120 students, and I actually do have 120 Algebra 2 students. There are test scores had a normal distribution of 80%. Now, test scores usually aren't normal. Most of the time, they could be, but they're not normally normal. That's kind of redundant. So 80% is my average test score, and my standard deviation is 6%. So we're saying for some reason these test scores came out normal. They made this shape. So what you have to realize is, I'm going to write on this thing, that 80% goes right there. That would be the mean, the middle, for this certain problem. Now, if 6% is my standard deviation, well, what would this line represent? 6% larger than my 80. So this would be 86%. And what would be on the other side? What would be right here?
74.
6% less, so that would be 74%. So what that means is, if you got an 80% on the test, and this was a bell-shaped curve, you're right in the middle with everybody. Got it? Over here, 86% to 74%, that range, 65% of the students were in that range. Okay, of grades. They're within 1 standard deviation. So let's talk about who's within 2 standard deviations. Well, what would be that branch?
92.
Wouldn't that be 6 plus another 6? So wouldn't that be 92%? And if I got down on the other side, wouldn't that be 68%? So what that's saying now is between 68% and 92% on the test. So from a D plus to an A minus, we have what percent of our students? 95% of the students should have grades in that category if it was a normal distribution. If it was normal. So are most of my students in between these grades? Yes. Does that always happen in a class? No. You have people with 10%, 0%, 100 and something percent. So it doesn't normally make a normal curve. But that's what's happening. And can we keep going? Could you figure out this? Add another 6, 98. Take away 6, is that 62? Okay, questions? So the next question is, what test scores are one standard deviation from the mean? So isn't one standard deviation from here to there? So can you see the test scores? Which test scores are from there to there? That's all you do. Oh, from 74%, and it would be 86%. Aren't those the two standard deviations that are one standard those are the 2% of test scores that are one standard deviation from the mean. Now, anything between that is within one standard deviation from the mean, but these are exactly one standard deviation from the mean, according to that number and that number to start with. Now, the next question is, what scores are two standard deviations from the mean? Well, two standard deviations, if you look right here, is right there. So we're going to jump all the way to 92 and all the way to 68. So that's going from 68% and 92%. Those are my edges. Those are the two standard deviation, but anything within two standard deviations would be anything between these values. So what percent of the students got between 68% and 92% on the test? From 68% to 92%, can you tell that would be within two standard deviations? And if you think about that, on a normal distribution, isn't that 95% of the people? So this would be 95% of the students would be in that interval. Now the next question, what percent is between 80 and 98? So from 80 to, well, if we add 6%, would that be 98 right here? So at the upper third standard deviation. So we're going from here to here. That is almost 50%. Basically, you almost could say 50%, but there's this little bit sliver. So there's really a teeny bit missing over here. So this would be a 49.85% of the students, almost 50%, are from here to the third standard deviation. The reason I got that little bit left is if you think about this, let's draw a couple things on this thing. Are you okay that right here, if this is 68%, this whole thing, you can hopefully understand I can write this as 34% and 34%. So each side would be 34% of your data. So if this is 95, well, these two have to add up. This is 68, so these two have to add up to the rest, coming up to 95. So what would that be? Well, the difference between these two is 27. Half of 27 is 13.5%. So these are both 13.5%. So if you add this, if you add all these, they should add up to 95% of your data. And if you keep going like this, you keep filling all of them, that outer one out here is 0.15. The reason I know that is, look right here. I have 0.3% here and here. Half of 0.3% is 0.15. So each of these edges is 0.15. So I took 0.15 away from 50%, because from here to the edge, it's 50% of the data, half. And I took away that little sliver. Kind of weird. So the next question is about how many students got grades one standard deviation from the mean. So one standard deviation is here to here. So it's these grades got it, but how many students got it? Well, if 68% of the students should be within one standard deviation, well, what's 68% of my 120 students? What is 68%? Well, isn't that 0.68 times 120? So what would that be? Approximately, what would that would be 81.6. Now you can't have 0.6, so let's just say that's 81 students. So 81 students are within one standard deviation. Okay, the next question is how many students got grades from one standard deviation to two standard deviations of the mean? Ooh, that's a little trickier. That's not saying within two standard deviations, because within two standard deviations, 95. But between one standard deviation and two standard deviations, above the mean. Ooh, mean. Okay, we're doing above the mean. So what this is saying is between one and two standard deviations above the mean. Isn't that above the mean? This is below the mean. This is above the mean. So I want this little gap of people. I want the people between 86% and 92% is what this is saying. But I want to see how many students, not percent. It's kind of like this question. This is percent of students. But now I have to then find, well, if 120 students altogether, and go from there. So 1 to 2 standard deviations above the mean is this gap. So I want to here take 13.5%, which is this, of my 120 students. And when you do that, what do you get? You get 66.2 students. So approximately 66.2 students, which would be, let's just say, 66 students. Because that's my percent of the 120. So we're kind of taking this information from above and going another step. Now for this question, about how many students got grades above 86%. So 86% is right here. Above 86% would be all of these forever up. Okay. So that would mean everybody from here all the way to here. So all of that. So we have to look at this percent. It could be this, it could be that, but what would this little be? Well, if you think about it, it takes a little bit of math because it's going to be kind of tricky, but this is 99.7. This is 95. So we got to find these two that add the difference of those. If you kind of break it down, what you're going to catch on to is this is going to be 2.35% in that gap. All right, because this, and this add up to 50%. So it's a 2.35%. So what would it be from here to here? What percent do you get when you add all that up? What you'll come up with is 16%. So 16% of the data of 120 students, we multiply that out, and we get 19.02, which would be 19 students. So how many students, again, got grades above an 86%? Only 19 of them. Because, again, 86 is right here. That's above. I added all that. If you kind of look at this bell-shaped curve and look at these percentages, you could see that would be 16%. So what would be below that? This is 16%. What would be below is 84% would be below that if that was the case. Next, how many students got grades below 68%? So 68% is right there. So for 68%, I went from here down. Well, what percents are over here? Well, isn't this same as these? So what are these two going to add up to? So when you add these two right here, you should know that's 2.5%. So we're going to have 2.5%, which is 0.025 times the 120 people. And when you multiply that, you get 3. The 3 students. What that means, again, is 3 students would get below 68% because you only have 2.35 plus 0.15% of the kids down here below that grade. Normal distribution. This is all based upon a normal distribution. Not all data, no data is actually perfectly normal, really. So normal is just a trend that looks like this bell-shaped curve. It's data that varies randomly from the mean. 68% is here, 95s from here to here, and 99.7s from here to here. Almost 100% within the 3 standard deviation. You just might have some outliers out here.